Hello friends, today we are performing our next practical, that is static measurement of subtransient reactance of salient pole alternator. So that means we have to determine subtransient reactance of given salient pole alternator. So here we are having three important things, that is salient pole alternator, second is subtransient reactance, and last one is static measurement. So title suggests we are having a salient pole alternator. We have to calculate subtransient reactance of the alternator. So why we are required to calculate subtransient reactance? Basically, when there is a dead short circuit is happened at the terminal of the alternator, so the huge amounts of current is flowing in the alternator. Okay, so to limit that current, we are having subtransient reactance. Okay, so already we know that we are having two reactions theory, that is direct axis, quadrature axis. So we can calculate it using that direct axis reactance, quadrature axis reactance. Okay, so by the extension of that, we are calculating subtransient reactance. So see, in afterwards, we are just looking for what is in the subtransient reactance. Okay, third one is the static measurement. So in previous machine tool subject, we have calculated XD and X2 by using slip test. Okay, but here we are calculating subtransient reactance in terms of the static test. Okay, so there is no rotation of the rotor of the alternator. Okay, so this is next one. What is the apparatus? So these are the apparatus which is required. Okay, first of all, alternator is required. You just go to the library, find out the nameplates and write down the details over here. Then what different equipments we are required? Lamp bank, ammeter, voltmeter, multimeter and connecting wires. Okay, so these are the range and the quantities. Now, the next one is the circuit diagram. If you see, this is the circuit diagram of the alternator. Okay, and this static test. So this is the alternator. This is the alternator having armature winding. This is a field winding of the alternator. So if you see, it consists of lamp bank, variac, single phase supply, for the measurement purpose, ammeter, voltmeter. So what is the main procedure to do that? First of all, we have to construct likewise two phases of the alternator. They are connected with the single phase supply in series with the lamp bank, and field winding is short circuited by using the multimeter. Okay, that is the main thing. That is the circuit diagram. Okay, now we are looking for the observation table. Inside the observation table, we are getting this condition: IF max, IF minimum, IF max, IF minimum. There is a voltage, there is a current. Okay, so this is the observation table. Now we are looking for somewhat the theory related to the this particular case. Okay, so in case of the XT and XQ, in case of the XT, basically we are having three periods. Okay, when there is a fault is occurred at the alternator terminal, so we are having three different periods. First is subtransient period, then transient period, and third one is a steady state period. So I am just given you the diagram, so then you can easily understand. This is a waveform of symmetrical short circuit of armature current in a synchronous machine. So there is a y-axis symmetrical short circuit current. There is a x-axis, we are having that time, and this is a waveform of the current. So we can see subtransient period, transient period, and steady state period. Okay, so in the subtransient period, we can calculate subtransient reactance, XD double dash. Okay, then transient reactance, XD dash, and last one the steady state reactance, XD. So in case of the subtransient reactance, we can calculate by using this particular waveform. So how it can be calculated? So XD double dash is equal to open circuit voltage divided by this current value, OC. Okay, so we can get subtransient reactance, Eg double dash. Okay, now we have to calculate, for example, you have to calculate Xg dash, transient reactance. So same way, open circuit voltage divided by OB. And last one, steady state reactance, open circuit voltage divided by OA. Okay, so here we are getting a equation also. If you are calculating the current, okay, so same way, vice versa, you can calculate it. Our main point is I double dash is equal to Eg divided by Xg double dash. Okay, so that is the main thing. Now next one, if you have this diagram, I just point out. So we are looking for the procedure. Next one we have procedure. But before going to procedure, we have to find out reactance offered by the machine under sub-transient state. We are having the approximate model. So first of all, when there is a fault occurs, we are getting this particular approximate circuit model where there is a damper winding reactance. Next one, field winding reactance and armature reactance. Okay, and this is the leakage reactance of the field winding. So we are getting all the values, they are connected in parallel. Here we can calculate a value of X double dash. Okay, so there is a 3 reactances, they are in parallel, and if you calculate the equivalent reactance, then you have to add a series leakage reactance of the field winding. So we can calculate sub-transient reactance. Next one, in the next model, we are getting a transient period. So the damper winding reactance is neglected, or you can just remove, and we are getting this one. And last one, Eg value. Okay, and the synchronous reactance. So next one, what is the procedure? In the procedure, we are doing for the static phase, make the connection as per the circuit diagram. We know that our circuit diagram is. Then I just given you the main diagram, then you can easily understand. By using the diagram, we can understand. So first of all, variac is in 0 positions, lamp banks, all lamps is off positions. Field winding is short circuited by using the milliammeter, and afterwards we are given the single phase supply. When there is single phase supply is given by connecting this particular switch, variac is gradually increased up to 230 volt. Afterwards, the lamp bank, few lamps is we have to blow. We have to on the lamp one by one. Make sure that your current should be below the 50% of the rated value of this particular armature winding, correct? So if you are getting that particular lamp on, afterwards manually rotate the rotor. Okay, afterwards we are getting the reading. That value we can calculate it. I just find out in the observation point of view. We are having some kind of virtual lab. So this is a virtual lab, our laboratory. Okay, so you can go through that, you can find out. So we are looking for the observation. He can see the current and the voltage. So you will observe that there is a deflection of current and there is a deflection of voltage. Okay, so that you have to be observed in case of this particular case and take down the reading. So in case of the observation stable, we are find out the readings, voltage and the current. If you go in, so we can calculate the calculations afterwards. So then IF max, direct reactive transient reactance, subtransient reactance, you can calculate it Xt divided by E upon 2I. Okay, and Xt is equal to E upon 2I. Two values we are getting because we are having two phases. Okay, so that's why we are taking two values. Okay, so Afterwards, same way we can proceed for the few lamps again on and find out the same procedure and find out the XD. Make sure that your loading is having 50% of rated current. Okay, and we have find out the XT and XT. So again, by using this, we can easily calculate sub-transient reactance and of the alternator. Okay, now by using this, we can calculate it by using sub-transient, transient, and last one, steady state. It is very much helpful to select the circuit breaker of the alternator. We have to protect, right? When there is a short circuit, we have to protect the alternator by using the circuit breaker. And how we can select the circuit breaker? By using the XT, the steady state, transient, and sub-transient current. Okay, so for the sub-transient current, it is vitally important to calculate SG double dash. Okay, so that's why afterwards you can select the circuit breaker. Afterwards, we are going through this particular question, solve it. Very simple question. What are the various types of fault? What do you mean by direct axis, quadrature axis of silent pole alternator? Okay, explain in detail sub-transient reactance, transient reactance, and steady state reactance of unloaded alternator when there is a short circuit takes place at its terminal due to appropriate stage. Okay, so we are going through this one. Okay, then thank you. Thank you so much.